Hi everyone! We are Team 20 of the MEC 410T Summer 2021 session. I am Talisha, and with me are Joshua, Jonah, and Amy. Today, we'll be sharing about our research, which is titled A Discussion on the Potential Societal and Environmental Impacts of Geoengineering and Artificial Weather Modification. In this video, we'll be going through four main portions. First, the background, then a case study on cloud seeding, followed by ethical and societal implications of geoengineering, and last but not least, the rules and regulations. So, to begin, I'd like to introduce what geoengineering is by providing you with a definition from the New Oxford Dictionary of English. Geoengineering, or also known as artificial weather modification, is the deliberate large-scale manipulation of an environmental process that affects the Earth's climate in an attempt to counteract the effects of global warming. Geoengineering has potential side effects that are detrimental to the world and to people. Firstly, the potential socio-political effects of geoengineering include the potential of geoengineering techniques and research findings to be misused and abused and weaponized. Secondly, the environmental side effects range greatly, from requiring rare earth metals for new technology, energy required to be consumed to deploy geoengineering techniques, as well as changes to the environment's chemical balance by introducing substances such as sulfur gas into the atmosphere. Following that example, sulfur gas used as reflective particles to cool the planet causes acid rain, which has devastating effects on the environment. Lastly, geoengineering requires a large amount of money, which diverts investments and cash from other causes, which are arguably just as important or more important than climate change. On the other hand, one must realize that there are benefits to geoengineering, especially since the phenomenon was developed to help the planet and all the living organisms on Earth. Climate change has caused devastating effects on our planet. In many parts of the world, temperatures have increased by more than 1.5 degrees Celsius, and the increasing occurrences of drought are causing devastating economic impacts. In response to this, geoengineering can cool the planet and increase plant productivity through stratospheric aerosol injection, therefore increasing food security in a world with a growing population. Geoengineering can also prevent weather-related disasters, such as floods and wildfires. One example of geoengineering success stories is cloud seeding, which will be explained more later in a case study. As of now, more research is being done to find ways to implement geoengineering and to use it for the greater good of our planet and people. All of these pros and cons beg the question, how can we keep the good and manage the bad? Our research builds on this background information, introduce and analyze case studies while discussing the true value of geoengineering and where it can fit in our society. Existing regulations and potential ways to mitigate risks will also be studied to ensure there are ways geoengineering can succeed on the day when it is indeed deployed on a large scale.
Although geoengineering is a relatively new field, cloud seeding has been used for many years. Hail suppression is one of the most studied and longest used weather modification methods. Mendoza, Argentina has been using cloud seeding for hail suppression for over 60 years. In the next few slides, we will review the published articles on the physical effects of cloud seeding and how we can use our current knowledge to build rules and regulations for engineers in geoengineering. So, what are some motivations for cloud seeding? In 2020, a single hailstorm caused an estimated 1.2 billion in damages in Calgary, Alberta. For many years, local insurance companies have invested millions in cloud seeding plans to reduce crop and property damage caused by large pieces of hail. Silver iodide is released into the air to encourage smaller hail formations. There have been a few studies on the long-term effects of cloud seeding. In a study published in 2021, researchers Researchers measured the silver iodide in the surrounding regions of Aragon, Spain, where cloud seeding has been used for over a decade. They found that the soil contained negligible amounts of silver iodide, and they theorized that plants and field animals safely absorbed the excess silver iodide and reduced the accumulation of the chemicals in the soil. High levels of silver iodide have been shown to slow fish, fungi, and algae growth, but the physical detrimental effects of silver iodide were not seen in the study. An aspect of water modification that cannot be studied is its efficacy due to uncontrolled variables in the environment. There have been several contradictory studies trying to prove the efficacy of cloud seeding. There are a few potential rules and regulations we can derive from our current use of cloud seeding. First, geoengineering should always use chemicals that are inert after it's been deposited. Next, the interaction of the substance with plants and animals should be studied to minimize harm to living things. Reducing biomagnification should be a priority, as the substance's passage through animals could be safe but become unsafe when consumed in large quantities by humans. Although it has not been covered by any studies, the chemical used for weather control needs to be tracked to reduce the unintended chemical accumulation outside of the targeted area. Lastly, engineers should have to be cognizant that there is no efficacy data on all forms of geoengineering. There are several contradictory studies on the efficacy of cloud seeding. Some countries reported no difference in hail size, while others reported a drastic reduction. Geoengineering is hard to study in a controlled manner due to the uncontrolled nature of our environment. Additionally, geoengineering should not be a distraction from existing proven methods to slow climate change. Lastly, geoengineering should not create extreme weather conditions outside the targeted region. I will now turn it over to Josh, who will go over the potential ethical and societal implications of geoengineering.
The potential advantages for geoengineering are significant, but there is the risk that this technology might disproportionately benefit certain countries to the detriment of other countries. As with many new technologies, regulation and guidelines need to be developed to ensure that the technology is used equitably. In a peer-reviewed study conducted in 2012, the author discusses the ethics of geoengineering with respect to sulfate aerosol engineering. Sulfate aerosol engineering is the process of injecting sulfate aerosols into the stratosphere in order to reflect incoming solar radiation. This has the potential to combat global warming by reflecting incoming solar radiation, thereby decreasing the global average surface temperature. In theory, this would allow humans to control the Earth's temperature by altering the concentration of sulfate aerosols in the atmosphere. However, sulfate aerosol has additional risks which include ocean acidification and alterations in regional weather patterns. These risks cause significant ethical concerns. Ocean acidification causes dramatic impacts on biological systems and causes decreases in the yields for fish. We can compare two countries, Russia and China. Russia, who has a low reliance on fishing for the national GDP, while China has a large reliance on fishing for the national GDP. Both these nations will be negatively impacted by increases in global temperature due to global warming and would benefit from the usage of geoengineering. However, China will be more negatively impacted than Russia with the side effects of ocean acidification. China has a greater reliance on fisheries for their national GDP. The resulting decrease in fish yield due to ocean acidification is unfairly distorted to disadvantage China relative to Russia. A loss in GDP due to ocean acidification will be far more damaging to the Chinese economy compared to the Russian economy. Geoengineering and geopolitics are closely related topics. Geopolitics is understanding how the world is known and imagined, and determining how space is known surveyed, and dominated and ruled. In essence, geopolitics is about the present state of the world. Accordingly, geoengineering is shaping the future of the planet. Geoengineering can be politically and ethically dangerous with the unilateral action of a country, which can have direct impacts on another country. Furthermore, geoengineering could cause unforeseen negative and irreversible effects, which can escalate into conflicts between countries. In addition, combined and coordinated effects by multiple countries would be likely more effective than uncoordinated attempts by individual states.
For any potential implementation of large-scale geoengineering, a robust system of rules and regulations must be put in place. Stakeholders must be consulted, and consent must be obtained from those who may be affected by the downstream ramifications of any project. Though geoengineering governance is still in its very early stages, some attempts have been made at formalizing the requirements. One attempt to create a preliminary system of principles to underpin geoengineering governance is the Oxford Principles. These 5 principles work to lay a groundwork for future geoengineering legislation and regulation. The first principle is that, while private industry should not be excluded from geoengineering deployment and research, and in many cases should actually be encouraged, all regulation should be done by the public sector and always in the public interest. This ensures that there are no conflict of interest in any geoengineering project. The second principle is that of public participation. At all stages of the research and deployment process, all stakeholders must be notified, consulted, and, whenever possible, informed consent must be obtained from the public. The third principle is that all research, whether positive or negative, should be publicly displayed with free and open access. This will both help the public to make informed decisions about geoengineering projects as part of the stakeholder consultation process. It will also help to alleviate public fears about geoengineering research by allowing them to see both the positive and negative results of that research. The fourth principle is that all geoengineering research should be assessed by independent third parties who are not involved in the regulatory or research process. This will, again, help to avoid any conflict of interest in deployment, research, or regulation. The fifth and final principle, and perhaps the most important one, is that of governance before deployment. A robust and full system of governance should be completely in place and fully developed before any geoengineering project is deployed. Overall, there's still much work to do before geoengineering projects could be deployed or research can begin. There are hurdles to overcome, both in research and regulation, that must be surmounted before an ethical and effective geoengineering framework can be deployed and developed. As well, much more work must be done to ensure equitable outcomes from geoengineering projects, from the creation of a powerful regulatory framework to the involvement of the global public and community in all steps of the process, from inception to deployment. Geoengineering may have fantastic benefits for the future of the world and may help to alleviate a lot of the problems that climate change will possibly bring. But it can also, if not done properly, have significant deleterious effects on the future of the world. Thank you very much for listening.